Hello SL2. Today's topic is the product rule and the quotient rule. From just some background knowledge on the product rule, we know from a previous class that if f of x equals u of x plus v of x, then the sum derivative is u prime of x plus v prime of x. So the question would be, if f of x was a product of two functions, u of x times v of x, would the same logic occur? Would the derivative of that f of x be equal to v prime of x times u prime of x? Well, let's use an example to see if this is the case. And if we have f of x equals x times x to the 1/2 power, we could say that u of x equals x and v of x equals x to the 1/2. So we have a product here, x times x to the 1/2. If this was true, then the derivative would be 1 times 1/2 x to the negative 1/2. However, we know we could add our exponents here since they have the same base, and this function would be equal to x to the 3/2. And we know from the power rule that really the derivative is 3/2 times x to the 1/2. So as you can see, with just a simple example, the same logic does not work for products that does for when you have a sum of two functions. So we have a different rule that we have to follow anytime we have a product of two functions. So when we have y equals u times v, then our derivative of y respect to x is equal to the derivative of u times v plus u times the derivative of v. There's another way to write it with the prime, and we would say that as y prime is equal to u prime of x times v plus u of x times v prime. Okay, let's look at some examples. Here's a first example for the product rule, and I'm going to use the way it's written on our packet, our blue packet, and that's how you'll see it on the IB exam. I'm going to use that way, how the product rule is written. Remember that this is the same thing as the prime, it's just written in a little different format. So let's take a look at our y, our number one problem. Our y is the square root of x times 2x plus 1. So to find our derivative of y respect to x, we're going to lay out what our u of x is and our v of x are, and take the derivative of those two. Then we will plug into this formula. So for this example, our u is the square root of x and our v is 2x plus 1. Our derivative of u in respect to x, using the power rule, we'll change this exponent so that it makes it easy to use the power rule. So remember, the square root of x is equal to x to the 1/2. So our derivative of u would be 1/2 times x to the negative 1/2. Our derivative of v in respect to x is just 2. So now we will plug into our formula to find our derivative of y. So our derivative of y with respect to x is the derivative of u times v plus our derivative of v times u. And we're just using this formula. So our derivative of u is 1 over 2 times the square root of x, and that's just moving this exponent down, times our v, plus our u times our derivative of v. So that would be the square root of x times 2. Now we will combine like fractions. And our common denominator would be 2 times the square root of x. So I'm going to go ahead and multiply over here by 2 to the square root of x over 2 to the square root of x. So we will have 4x over 2 times the square root of x. Now we have common denominators, and we can, our final derivative simplified as 6x plus 1 over 2 times the square root of x. Okay, so let's try another problem. Number 2, we have a product of x squared times x squared minus 2x to the 4th power. And let's go ahead and try the other way the product rule is written with prime. So that would be y prime equals u prime times v plus v prime times u. And our y is our entire function here, x squared times x squared minus 2x to the 4th. Our u would be x squared, and our v would be x squared minus 2x to the 4th power. Our derivative of u, or our u prime, would be 2x. Our derivative of v, using the chain rule, we would multiply our exponent times our coefficient here, so we have 4. We leave our inside the same, x squared minus 2x. We subtract 1 from our exponent. Then we multiply by the derivative of the inside, which would be 2x minus 2. Okay, let's go ahead and simplify this, our derivative of v, and we would have 8x minus 8 times our x squared minus 2x to the 3rd power. Okay, so now we have all of our parts to our problem, and we're ready to plug in to find our derivative of y. Okay, so let's find our derivative of y, and I started recording and it was running out of space, so I'm just going to go straight down and extend the page here instead. So our derivative of y, we're just going to be plugging into our formula. Our derivative of y prime, is going to be equal to u prime times v plus v prime times u. So u prime times our v plus v prime times u. Okay, let's go ahead and simplify. And if we multiply here, we have 8x cubed minus 8x. and times the x squared minus 2x to the third power. Okay, so we found our final answer for this product, our problem number 2. Our derivative would be our 2x times x squared minus 2x to the fourth power plus 8x cubed minus 8x times x squared minus 2x to the third power. Alright, now let's do the quotient rule. A quotient rule is just like it sounds. It's when you have the quotient would be equal to u of x divided by our v of x. Then our quotient, our derivative of our q would be equal to u prime times v minus u of x times v prime all over v squared. Okay, on your formula sheet it is written this way, so I want you to be familiar with that. You'll be using this formula sheet all year and then on the IB exam. And you can see it's written very similar. We have our y equals u divided by v, and our derivative of that y respect to x would be v times my derivative of u respect to x minus u times the derivative of v respect to x all over v squared. Okay, so let's try the first problem, and we have our y in this case is equal to u over v. Our u would be 2x plus 1 to the third power, and our v is the square root of x. And it's a good habit to go ahead and write those next to each other and then immediately find the derivative of those two. So our derivative of u respect to x would be using the chain rule. We'd multiply 3 times my coefficient here, and we leave the inside the same. We subtract 1 from 3, so it would be squared, and now we multiply by the derivative of the inside, which would be 2 in this case. Simplifying that a little bit, we'll just multiply 3 times 2 to get 6. Okay, so our derivative of v, we'll go ahead and change our v to x to the 1/2 to make it easier to take the power rule. Our derivative of v would be 1/2 times x to the negative 1/2. Which would be the same thing as 1 over 2 to the square root of x, 2 times the square root of x. Okay, so the last part is now we have all of our parts to plug into our formula, and we will just do that and then simplify. So our derivative of y respect to x is, and this is really important, you want v times the derivative of u minus your u times the derivative of v. So our v is the square root of x times 6 times the 2x plus 1, which is our derivative of u, minus our u times our derivative of v. All over v squared. In this case, our v is the square root of x, so if we square the square root of x, we're going to get x. Okay, I'm going to go ahead and pause the video and allow you to simplify the numerator. Combine our numerator here so that we don't have a fraction being divided by a fraction. So I'm going to go ahead and pause the video, allow you to finish that, and then check your work. Okay, so here's our final answer for our derivative of our first quotient. And remember that you cannot factor, you can't cancel here because there's not a factor of x and 2 in this item as well. So that would be your final answer.